Alright, so I want to just quickly demonstrate a visual demonstration of my repaired form of the Archimedean principle, how it only applies to finite values, and that includes the transfinites. The transfinites, for all intents and purposes here, are finite. Right? The fact that you can never actually get to them within a set amount of time or whatever, that's not really the concern. What the concern is because transfinites are still well ordered, they are ordinals, they act as bounds. So they can be manipulated arithmetically. Right? So here, if we take something like y equals x squared, where is it going as x increases? Where is it going? As x moves away from y, where are we going? Very rapidly, we're just disappearing into very large positive values. Right? So the attractor to this, it doesn't care. You know, if we add 1 to this, if we add 2, if we add 3, if we add 4, right? This is where, like, Cantor normal forms would come into play, right? You add 4 to this kind of thing, and yeah, I mean, technically you did it, but, and so there's an ordering to it, but it's so far out there, do you really care? But also, because they're ordered, those aren't the attractors, those aren't what the attractors are, right? So, like, we can divide by, you know, various things. And we can grow this out, make this fatter. But if I zoom out far enough, by the time we get to large enough values, it looks the same anyway, right? And we still haven't reached the attractor. We still haven't reached the value that is actually pulling this in. So, what's really happening? It's being attracted by an infinite value. And this specific thing is not ordinal. It cannot be manipulated via arithmetic. Now we can see that it also has an inverse. There you go. What's the inverse of this? So now we're looking at as x increases, we're still looking as x increases. It very quickly approaches 0. Right? And it's never going to pull up above that. It's never going to pull above that, and it's always getting closer and closer to 0, right? No matter how far out we go. So the inverse of our infinite attractor is 0. 0 is a specific value. Okay? So the inverse of 0 is also a specific value under a certain line of logic, right? But this specific value does not cooperate with arithmetic, right? You cannot define it in terms that can cooperate with arithmetic. And you can also see that this is occurring here, where x is 0. When I take the inverse, suddenly it behaves like the whole parabola did previously. It's exploding to infinity. Its attractor doesn't care how we manipulate it. arithmetically. Right? The modification doesn't change anything. Alright, I can add, I can subtract, I can multiply, I can divide. It doesn't matter. It's not affecting it. Arithmetic doesn't have any effect. What this is now doing is now, instead of approaching 0, it's now approaching 90,000. Right, so this, boom, right, because this was the thing we were manipulating. But let's see, let's do this. No, that's not where I want that. I want that here. Let's do plus 10, 100, 1,000. Right, so that's going to just walk it left and right. Right, so we can move things. We can move it around. That's fabulous. It doesn't really matter. The principles at play are the same. The attractor is infinite. It's not bounded. It's not a bound, right? So it's not an ordinal. It has an inverse, and its inverse. Its inverse isn't really 0. So if we look at this, its inverse isn't really 0. Its inverse is right next to 0 because it carries a sign. See, it can carry a sign. You can have a positive or a negative one. Alright, so it's not 0. 0 can't carry a sign, so it's the neighbor to 0 on one side or the other. The literal successor to 0. It's not an ordinal, but it is the successor to 0. Right? I don't understand how this isn't a standard concept in modern mathematics, because you can see that that's necessarily what's happening if you've ever looked at a fucking graph. If you've ever done this, if you've ever actually tried to take limits and graphed things, you see that this is exactly what's happening. So I don't understand why nobody understands this, and we're all going to be foot stompy and say, oh, the Archimedean property applies absolutely everywhere. It doesn't. When you're dealing with the neighborhood of the inverse of 0, it doesn't work that way. It's no longer ordinal. You are actually down at like an atomic level. Like there is, in order for there to be a continuous space here between, zoom in slightly, between 0 and 1, you have to be able to go from 0 to some other value. If 0 doesn't have a neighbor, which is what the Archimedean property literally tells us, if 0 doesn't have a neighbor, how do you ever get to another value? By moving through this space. How do you move through this space? What does that mean? And allegedly, that's what gives us a continuum here? That makes no fucking sense. There has to be a neighbor to this. And it also has to have certain properties, like arithmetic doesn't apply, it doesn't work over it. And if arithmetic doesn't work over it, then our proof for the Archimedean property is also invalid over it. And hey, look at that, now we don't have a problem. All of the paradoxes disappear if you just think about it right. And it behaves exactly as the graphs are telling us it behaves. We're not inverting 0 itself, we're inverting the neighborhood of 0, right? That little monad right around there that contains 0. But specifically, this right-hand limit as we approach 0, it is ideally tracking. The attractor to this whole thing is the inverse of the right-hand neighbor of 0, the successor to 0. Or, as I've labeled it previously, L0. Terrible naming convention because it conflicts with all sorts of things like Lagrangians and all kinds of other bullshit. But, whatever. I don't really give a shit because it's not like the rest of this house is well kept, so I don't care if I'm making a little bit more of a mess. But yeah, and then the left hand is negative, as you can see. It's going down here. Positive, and let's just do, there's another version where you can see you get positives and negatives, and let's do, so you can see where this is actually occurring. There we go. So it's on this line here. This is our asymptote. Up here, we get a positive version of it. Over here, we get a negative version of it. And this is specifically where, so tangent is opposite over adjacent, right? This is where your adjacent side, the base of your triangle, goes to 0. But we have, it goes from positive to 0, and then over here we're going negative to 0. So this carries a sign. You get this positive infinite value and this negative infinite value. And it's not transfinite. It is not well ordered, right? The concept of ordering doesn't apply here. We're looking at things that are more like just straight cardinalities, like all F0 or something like that, all F1, something like that. It's not an ordinal. Cantor's normal forms do not apply here. You cannot take this value and add 1 to it and get something larger than what you had. We're in that territory where Hilbert's hotel is operating, right? There is no order to this, right? It's not an ordinal. There's no order here, right? Arithmetic does not affect this.